Number 1, given the sine of theta equals 3/5, and theta is between 0 and pi over 2, we want to find each of the following. Well, the hardest part on half angles, because that's what we're going to be finding, the sine of theta over 2 and the cosine of theta divided by 2. The hardest part of those is determining whether our answer is going to be positive or negative when we finish the problem. And that's what our first step says here almost. It says, determine the quadrant that the triangle is in. Well, here's 0 and here's pi over 2. So the good news is we are going to be working in quadrant 1. We're going to draw our triangle so that we've got that bow tie. Here's our right angle. I'm a little bit off. But a reminder, once again, that across from the angle is the opposite. And across from the right angle is the hypotenuse, which means over here that this is the adjacent. And we know that sine is the opposite divided by the hypotenuse. And some of you recognize this as a Pythagorean triple, and you don't even have to do the Pythagorean theorem, because you know what the adjacent length is. But if you don't, then it's going to be a squared plus 3 squared equals 5 squared. So we get a squared plus 9 equals 25. Subtract 9 from both sides, and we get a squared equals 16. And then we take the square root of both sides, and we end up with a equals 4. And that's not the hard part on this particular problem. What we need to figure out now is what is going to be the sign, the SIGN, whether it's going to be positive or negative when we finish. Our formula, as a reminder, is going to be plus or minus. It's going to be the square root of 1 minus cosine of theta divided by 2. You will not be required to memorize those, so I just had to take a moment and look at it. But if you think back to what our directions are, because we drew the triangle, we found the missing side lengths, we've determined which formula to use, and now we need to figure out whether our answer is going to be positive or negative. And what we're going to do is, instead of 0 and pi over 2 for this half angle, what we're going to do is we're going to think of it in terms of, well, let's think of it as 1. So 1 more than 0. And 89 degrees. It's easier to think of that. So it's going to be in this quadrant, so somewhere in between there. And if we cut 1 in half, we get 0.5. If we cut 89 in half, we get 44.5. Well, 0.5 is in quadrant 1. 44.5 is also in quadrant 1, which means that we're going to have a positive value for both of the answers here on A and B. Now, what I neglected to do so far is I need to identify here what is the cosine of theta. So I look over here at a triangle, and remember that cosine is the adjacent divided by the hypotenuse, so we're going to have 4/5. And now we're going to fill that into our formula. And it's going to be the square root of 1 minus 4/5 divided by 2. And I know I haven't used the calculator much, but if we go to the calculator And I'm not going to type in the square root. I'm going to go alpha y equals, and we're going to type in this value. So it's going to be enter. So then it's going to be 1 minus alpha y equals 4 fifths, and then all divided by 2. So that's going to give us that value there of 1/10. So we type that into the calculator. It's nice, there were no square roots anywhere. So we get the square root of 1/10 when we do that computation. 1 minus 4 fifths divided by 2. Notice that I put that value back underneath the square root. And what that means from there is it means the square root of 1. It means the square root of 10. And the nice part on this is we can take the square root of 1 if we want to. But more importantly, what we need to watch out for is the fact that we need to rationalize. That means we want to get rid of the radical in the denominator, which is the square root of 10 here and the square root of 10 there. We're going to multiply both of those by that value. Fancy form of 1, if you will. We already know that our answer is going to be positive. We did that at the very first. But square root of 1 times square root of 10 is square root of 10. 10 times 10, square root of 100. Well, what does the square root of 100 equal? Well, the square root of 100 equals 10. So we end up with the square root of 10 over 10. And that is what our value of the sum of theta divided by 2 equals. Now, if you use up all your space, you might want to put part B on notebook paper, just so you've got space. But the cosine of theta over 2, let's look back at our papers and identify what the cosine of theta over 2 is. We look back at our paper and we see that our formula is going to be, it's plus or minus 1 plus cosine of theta divided by 2. We recently found that the cosine of theta is 4 fifths. And we also recently found that our answer is going to be positive. Since we're in the first quadrant already, and if we're working with half of a particular angle in the first quadrant, it's still going to end up to be in the first quadrant. So now we fill this in. We've got 1 plus 4 fifths divided by 2. And we can go over to our calculator and we can type that value in. One plus 4 fifths divided by 2. And when I press enter, we get 9 tenths. So that equals 9 tenths. I don't know why I switched colors. But a reminder here that when we've got a fraction, that means we're going to take the square root of the top of the fraction, and we're going to take the square root of the bottom of the fraction. And as we take a closer look here, we can take the square root of 9. It's 3 divided by the square root of 10. And what we don't want is we don't want to have a radical in the denominator. So we need to get rid of the radical in the denominator. So we're going to multiply the denominator by the square root of 10. If we multiply the denominator by the square root of 10, we need to multiply the numerator by the square root of 10. And when we do that, we get 3 times the square root of 10 over 100. And some of you need to write that step, and some of you don't need to write that step. But ultimately, what we end up with is 3 square root of 10 divided by 10.